चलिए दोस्तों शुरू करते हैं without wasting time. In this video, we will see how to configure the VXLAN EVPN in Cisco Nexus. Okay, and these are the few limitations I have mentioned for the traditional layer 2 network, like spanning tree, limited number of VLAN, and large MAC address table. And these are the requirements for the modern data center: agile, scalable, elasticity, mobility, and segmentation automation. So in the modern data center, we want to quickly add the new application or quickly want to set up the network that we can achieve with the help of automation. And modern data center should be the elastic. So elastic means without how we can do the changes in the existing network without affecting the existing application, and how quickly we can fulfill the new requirement with respect to application. It should be agile, and how we can quickly upgrade the network if we want to add a new leaf or new spine. That should be scalable. These are the few. And mobility, these are the few requirements on the modern data center. If we talk about the configuration part, if we have to configure the VXLAN EVP in the Nexus, so we need to configure underlay protocol. In the underlay, we need to configure the IGP. IGP can be OSPF, ISS, or EIGRP. The requirement of IGP to get the reachability between the VTAPs. Okay, so our leaf 1 and leaf 2. So and spine, all these are the VTAP. Okay, VTAP is you can say virtual tunnel endpoint, and main role of the VTAP is uh, to encapsulate and de-exclude the traffic. Okay, and PIM is required. We need to configure a PIM. Okay, to handle a bump traffic, broadcast, unknown unicast, and multicast traffic. And another option is hidden replication. Also, we can configure, as we have seen during the implementation in the BGP VPN in MPLS encapsulation, but that is not scalable. Okay, so when we configure the PIM, so all our VTAPs will be act as a multicast sender and receiver for each VNI, and spine will be act as a RP redundant point. For redundancy, we can use the Anycast RP, and to share the information of MAC or MAC IP, we'll configure the BGP L2 VPN address family. Okay, and to achieve the ECMP, how we achieve the equal cost multipathing in the VXLAN EVPN in Nexus. So we have a 5 tuple like source IP, destination IP, source port, destination port. Okay, so in all of these parameters, only one thing is changing, that is the source port. So on the source port base, UDP source port, VXLAN source port ports in the packet, we can achieve the ECMP. And VXLAN by default port is 4789 in the case of Cisco Nexus. Implemented with the same thing we will see in the Wireshark capture also. In the ACI is different. Okay, it's not the same port in the case of Cisco ACI. If we talk about the VXLAN EVPN overlay config, so we need to create a mapping between the VLAN and VNI. And VNI is nothing but a virtual network identifier. VXLAN, sorry, virtual, not virtual, it's in a VXLAN network identifier. So it's similar like a VLAN ID in the regular VLAN. Okay, and VNI, we have a two type: L2 VNI, L3 VNI. L2 VNI to exchange the traffic within the same subnet, or L3 VNI come to the picture when we'll exchange the traffic between the different subnets. This is the thing we will see in the Wireshark capture also. Once we had done the mapping with the VLAN and VNI, then we need to configure an interface which are connected to the host. So these are interface can be access or can be trunk port. After that, we will get the NV interface like a tunnel interface, network virtual interface, and then we'll proceed with the EVPN config to initiate the EVPN API. One of the feature when we configure the on the NVI on the tunnel interface, we can configure the for each VNI we can the ARP separation. ARP can simply mean that if host receive any ARP request, like this host, we have a host one, if receive a ARP if this will send a ARP request to the leaf one for this host 3. If leaf 1 have an already entry about this host, and leaf 1 have learned this entry with the BGP EVPN, he can simply reply for this ARP request. Okay, so this is how ARP separation work, but this is not similar as a proxy ARP. And in the Cisco connection, mostly we see the route type 2 and route type 3 and 5. Okay, as we know, route type 2 is to exchange the MAC and MAC IP, and route type 3 is for the multicast of the bump traffic, and route type 5 is the prefix IP prefix advertisement. If we talk about the topology, I have taken the three NXS 9K. Okay, these two are the leaf 1 and leaf 2, and I'm taking the only single spine, but in the production environment with the multiple spine. Like for the NC protectors, spine minimum will be a 2 you will see, and multiple leaf will be there. And these are the loopback 0 IP 1.1.1.1 and 2.2.2 on leaf 1 and leaf 2. And on the spine one, loopback 0 IP is 11.11.11, and this triple one IP which is configured in the loopback 1 or loopback 100 we have configured on the spine. So this is this IP we are configuring as a RP, as we need to support a bump traffic. To handle a bump traffic, uh, and spine will act as a RP. So this loopback IP will be act as a RP, and this IP address will configure the PIM, configure on the leaf 1 and leaf 2 also. Okay, and we will enable the IP PIM sparse mode on all these interfaces which are coming the leaf 1 and between the leaf spine, and also on the loopbacks, also on the SVI, which we get like for this host. IP address is 201.168.101. So SVI is connected here actually on the leaf 1. Okay, like we have the VLAN 100. On the VLAN 100 we have put the IP 201.168.1.1/24. Okay, similar way we have another VLAN configure. The VLAN is 200, that is acting as a we have configured as a L3 VNI, and we have a VLAN 500 that is belong to a different subnet which is subnetted 202.168.1.103, and for this SVI is created on the leaf one. So we will see how we can achieve the traffic reachability between the subnet and between the two different subnets, like from the 20. In the case of host connected between the same leaf, like host 1 and host 3 are connected on the leaf behind the leaf 1, so there will be no VXLAN encapsulation come to the picture. So here the forwarding will happen normal, and while host 1 and host 2 will communicate as they are behind the different leaves, so they have to travel this fabric. So VXLAN encapsulation come to the picture, and in the VXLAN EVPN we need to take care of the MTU also, as the fragmentation is not allowed. And these are the things we have. Let me quickly show you the configuration. So this is here you can see the configuration. Here I have put in the configuration with regards to IGP, which is the underlay configuration to achieve the reachability between the VTAPs. So in the Nexus, every time we need to configure protocol anything, we need to first thing we need to enable a feature. Here I'm enabling the feature OSPF. After that I'm doing the config related to the OSPF. Router OSPF process 1 is running. On the interface loopback 0, we are labeling the IP router OSPF area 0. Similar way, interface loopback 0, we are calling this IP process, and this loopback 100 is for the RP. And these are the interface we connecting with the leaf 1 and leaf 2. We have enabled the IP OSPF, and the network type we are using a point to point. Similar way here, this is the one where leaf 1. We have a loopback 0, and this is the interface connected with the spine. We have enabled the OSPF. This is a leaf 2, again feature router OSPF process 1, loopback 0, and this is the interface connected with the spine. Once we're done with the IGP, we have a reachability unicast routing in place between the VTAPs to get the reachability. Here we're labeling the multicast config. So again, we are labeling a feature PIM. After we configure IP PIM RP address. So this is the loopback 100 IP address, and this is the multicast group we are configuring. Okay, this is the anycast RP we are putting. Okay, and here we have enabled the IP pass on the loopback 0, loopback 100, and on the spine leaf 1, the interface which are connected with the leaf 1 and leaf 2. This is confirm the leaf 1. Okay, here again we are putting the IP PIM. This is the RP address. RP address, this is the loopback 100 address of the spine, and this is the group. And on the interface loopback 0 and interface connected with the spine, we have enabled the spin sparse mode. Similar way, this is the configure the leaf 2. Here also on the loopback 0, 1/2, we have enabled the IP sparse mode, and we have configured the RP address. Once we done that, after that we're proceeding for the BGP configuration. Again we are enabling the feature BGP, as this is the iBGP between the leaf and spine. So we are configuring spine as a route selector. Okay, And here I've confirmed this is a spine config, and on this spine this is the router ID. These are the two neighbor, leaf 1 and leaf 2. This is the loopback 0 IP address of leaf 1. This is the loopback IP address of leaf 2, and I'm configuring as a client. Here you can, this is the leaf 1 config. This is making IBGP with the spine, and this is the IP address of loopback 0 spine 11.11.11. Similar with this is the config leaf 2, again router ID, and this is the IP address of spine. And we have enabled the address family L2 EVP, L2 VPN, EVPN. So with the help of this address family, we were able to exchange the host MAC and MAC IP information. And here I have configured the VXLAN EVPN overlay config. Okay. First thing, we are creating a VLAN and VI mapping. So first I create the VLAN 100 and VLAN 200. After that, these are the VNI number I am defining. Okay. So I put this number. I put the loopback 0 IP address like 111111, and after that this VLAN number I've attached. So any VN segment number you can configure. Okay. So here you can see the one of the leaf configuration I've shown, which is connected with the host. So simply I've configured the switch port access like this interface is connected with the host one. So host one on the leaf one ETH one slash will a part of the switch port access VLAN 100. Okay. And here I create the SVI on this leaf one for this VLAN 100. VLAN 100 I put the IP address 20116 part of VRF. Once we're done with the BGP configuration, here labeling the feature network virtual interface NVI to configure NVI tunnel interface as this NVI like a tunnel interface only. We are labeling a feature after the NVI. So this is to exchange the host information with the help of BGP L2 VPN we are configuring, and source we are taking the loopback 0. So loopback 0 IP will act as a VTAP IP that will help in the decapsulation of the traffic. Here we come with the member VNI, which we have created the mapping with the VLAN 100. For the VLAN 100, this is the VNI. Okay. And here I'm configuring the features press R, which we have discussed. And for this VNI, this multicast address is configured. So whenever the bump traffic will receive for this VNI, for this VLAN 100 broadcast domain, so that will be join this multicast group. Okay. So this is the VNI associated with the VNI. This is the L3 VNI configure. Okay, so L3 VNI will come to the picture when we change the traffic between the two different subnets. Here I'm labeling the feature fabric forwarding, and after that here I'm calling the EVPN config. Under the EVPN, I'm calling a VNI. This is the VLAN 100 VNI, L2, L2 VNI, RD is auto. In the Nexus, we have a feature you can configure the manually also for the each VNI, RD and RT auto, or manually configure also we can do. Here you can see that we have got the VRF blue, and under the VRF this is the L3 VNI, and again here also RT for this EVPN we are putting the auto also. Here you can see this is the configuration of VLAN 100. Okay, I'm calling this under the VRF blue. So here this is the SVI IP. This is a simple tag as I have to advertise this route in the BGP. Okay, so I'm putting the tag. Okay, IP sparse mode is multicast enable and fabric mode is anycast gateway. As whenever the host, if on the leaf 1 and leaf 2, we are putting the same IP, this IP, and we have configured the anycast MAC also. Okay. And this is the configuration of VLAN 200. VLAN 200 acting as a L3 VNI SVI. So there is no IP configured, only keyword is configured IP forward, and is part of VRF blue. Here I've taken the few output in the leaf one, and with the source VXLAN showing the VLAN and VXLAN mapping 100 VLAN. This is the VNI, 200 VLAN, this is the VNI. Here you can see the NVPA details. So leaf 1 and leaf 2, this is the leaf 2 IP that become the neighbor, and this is the router MAC. Okay, this is the uptime, and these are the VNI configured on this. Or peer add complete means hardware programming is if they are proposing state, this you can confirm hardware programming in place. So these are the control plane learning. These are the VNI is learned, and VNI same symmetric as we know symmetric asymmetric. So here the symmetric is configured. Here you can the MAC address dynamic table. So this is the MAC address we are learning remote NVI interface. Here I took the output from the leaf one. So in the BGP L2 VPN RD we are taking. So this is the L3 VNI which we have configured the VLAN 200. I just said VLAN 200 VNet as L3 VNI. Here this is the L3 VNI, and these are the two received label. Inner label is this L2 VNI and the L3 VNI. Okay. Encapsulation means the VXLAN encapsulation. This is the router MAC. So this is the MAC address of the SVI which we have configured the VLAN 100. Okay. We'll see why this router MAC is required. Okay. And these are the things we have in place. These are the originator ID as we have configured the ARA. So this is the spine loop by zero address, and this is the originator. This is the leaf 2. So these are extended community again. Okay, and we'll see we'll see in this all this picture. Here you can see this is the uh, MAC only IP. This is the route type 2. Okay, so this is the Ethernet segment. As we not configure the Ethernet segment showing the 0. Ethernet tag is also 0. This is the length of the MAC address, and this is the actual MAC address of the host. Okay, and this is the prefix length. Prefix count is the 2160, and these are the few important things to note. Okay, and here we can see the MAC IP. So in the route type 2, EVP and route type you will the MAC only entry also, and the MAC IP. Here is the MAC, here is the IP for that host, and prefix count is 272. Okay, here the length is, and here you can see the blue VRF is blue, L3 VNI is this, L2 VNI is this. Okay, these are the C label again, L2 VNI, L3 VNI. This is the router MAC of the SVI. Okay, and here I took the output of show NVI VNI all from the leaf one. Here we can see that NVI one. So this is the local VNI L2 VNI control plane mode, and this is the type. Sorry, this is the L3 VNI, and below one is the L2 VNI where you configure the multicast group. For the each VNI, you have to configure the different multicast group to handle the bump traffic to overcome the interference. If we go with the same multicast group for the every VNI, then the duplication, or you can say the uninterested traffic will be received. And here you can see that this is the source IP 201.168.1.1 So this is the IP of host 1. This is the 201.168.1.1 This is the IP address of host 2. So this host 1 connect the leaf 1 and host, and this host is connected between the behind the leaf 2. Okay. So between the same subnet we are pinging. Here you can see that this is the internal packet ICMP internet control message ICMP packet. ICMP packet encapsulated with the, this is the source IP and destination IP we are trying to ping, and this is the MAC of this source and destination MAC. Okay, this is encapsulated in the VXLAN, and here you can see that as we are trying to ping between the same subnet, so in the VXLAN VNI is the L2 VNI. This is the VLAN 100 VNI which we've seen. Okay, here you can see destination port for the VXLAN using the 4789, and this is the source port. Okay, and after that is encapsulated in the VTAP IP address. So this is the VTAP IP address. So it's going from the leaf 2 to leaf 1. Okay, after that these are the IP address of the SVI router MAC. Okay, which we have seen in the route type 2 router MAC. So this is the SVI MAC. Okay, and here you can see that we are pinging between the two different subnet 2022 to 201. These are two different from the ICMP. Again, this is the ICMP packet. This is the source IP and destination IP. This is the MAC address for these IPs and destination MAC address. And now if you see in the VXLAN, VNI it is the L3 VNI, which is for the VLAN 200 we have configured. And where we have entered the SVI only, and there is no IP address we have seen in the configuration. Here you can see. Let me quickly show you again. So this is the L3 VNI. There is no IP, only IP forward command is there. Okay. Again, this is the VTAP IP. Under the VXLAN, we are using the L3 VNI. Destination port is 4789, and this is the outer header. Okay, outer IP address, L3 address, VTAP IP addresses, and these are the SVI MAC. Okay, router MAC which we use in the L2 MAC IP route. And if you have to troubleshoot how the end-to-end programming is happening, so first you check the ARP entry is there. Here we are checking the ARP entry on the leaf in the show IPR VRF blue. So you can see that on this leaf one we have a two entry. So these are the two SVI created, 101 and 103. So for these two hosts, we are learning the ARP entry in the VLAN 100 and VLAN 500. Okay. And after that, in the urgency manager, you can check the show forwarding VRF blue urgency. So here you can see the similar ARP entry program in the urgency manager. After the urgency manager, it will move to the program will happen in the host mobility manager. If you check the show IP route, for this here you can see the /32 route is created. Okay, and here you can the host mobility manager flag is set HMM. Okay, for this VLAN 100 I am checking. You can similarly check for the VLAN 500 also. And once the programming the HMM, then it will go to the L2 rib. L2 rib, you can check this command show L2 route EVPN MAC IP. EVI is the VLAN number I am putting. So here you can see the this is the production of HMM and flag is local. Oh, this is how you can check. Okay, and after that this route will be processed in the BGP for the further distribute with the other leaves. Okay, here we checking the show BGP L2 VPN EVPN. So this we are checking. It's showing the L2 VNI. This is the MAC IP route. Okay, this is the prefix count, and here we are seeing the received label L2 VNI, L3 VNI. This is the standard communities, and this is the router MAC, which we have seen in the outer header wire in the capture. Correct. So this is the SPI MAC. And one more thing you will see. uh, And one more important point to note that when we are checking the show MAC address table dynamic, here you can see the age timeout to 0. So in the case of BGP VXLAN EVPN, so this age timeout will be 0 as the MAC withdraw will be happen with the BGP withdraw message. Okay. So whenever the host will disconnect, so this leaf will initiate the BGP withdraw message. After that, your MAC will be withdraw. So that's why age timeout is 0. So here are the few commands. Let's do verification of this the few commands. Here we are on the leaf one. We do the show IP interface brief. This VRF blue. These are the interface part of the VRF blue. So VLAN 100. This connect to the host one, and this is for the host 3, and this is the L3 VNI. Okay. And if I check the BGP neighborship, show BGP L2 EVPN summary. So we have an this is the neighborship with the spine. Okay. If we check the route, what are the routes we are getting from the spine? We do the route. So here you can see we are getting a route type 2, Ethernet segment, Ethernet tag is 0, and we not configure. MAC address length is 48, this is the MAC only route, and prefix count is 21/6. 272 is the MAC IP route 2. This is the L2 VNI, okay, for the VLAN 500, and this is the L2 VNI for the VLAN 100, okay. And here is the route type 5, which is the IP only route, prefix route, okay. The this is thing you can see slash, okay. And here these are the routes we are coming from the 222 leaf 2, okay. This is route type 5 and this is route type 2. So MAC and MAC IP route are coming, okay. And this is the L3 VNI, okay. This is the local route, okay. So these are the things. And I'm checking what other route I'm advertising, advertise routes, okay. Here you can see these are the routes we are advertising. We are advertising a route type 5 prefix only route, okay. And we have an MAC and MAC IP route, okay. And if I do the show MAC address table dynamic, here you can see we are learning the remote MAC address from the NVE interface, okay. And age out is 0 as the MAC address withdrawal happens with the BGP withdraw message in the L2 family. So these are the VLAN. Again, we can check for the show VXLAN. So in that is a mapping. So for this 100 VLAN, this is the VNI. For 200, this is the 12.3 VNI will be the common. Okay. And these are the things we have. Okay. Here we are behind the host 2. Okay. So let's quickly check again. Show IPR. Okay. this is the entry at present heaven. This first show you the configuration. So only IP address configured there. Okay, this is the interface connected with the leaf 2, and I will configure the static route default route put toward the SVI which you configured in the leaf 2. So let's do the ping for the host 1 IP. Okay, 01. Okay, we're able to reach. Okay, we do the trace route for this host 1 IP which is connected behind the leaf 1, and this host is connected in the leaf. Just wait some time. Okay, okay, showing as it will take connected. Correct. Take now to the arc table. So we have an arc entry for this. Let's do the inter subnet 202.168.1.103. This is the host 3 IP which is connected behind the leaf 1. So we also let's do the similar trace route for this. Direct hop into the destination IP. So this is the first IP is coming from the SVI IP. This is the we have a spine. Okay, here you can see show IP OSPF mirror is the underlay IGP is one to OSPF and it's having a neighborship in the leaf 1 and leaf 2. And similar way for the multi-cast also we have a two neighborship leaf 1 and leaf 2 and show BGP L2VP and EVP summary. So leaf 1 and leaf 2 both have a neighborship. Show BGP L2VP and EVP. These are the route type 2 and route type 5, and we are getting from the leaf 1 and leaf 2. So it's the show IP M route to multicast. So this is the group we have configured. Okay, and show IP in RP. Okay, this is the RP address, which is the part into this on the spine. So this is how we can check the route for the subnet here. If you check the route, show IP route, we are do as we are pinging the 202.168.1.103 port 3 technique and the leaf 1. Let me get it direct. Okay. Okay, this is the route. It's learning. Okay. It's saying this is the SEG ID. So it's an 111120 the L3 VNI need to be attached. This is the tunnel ID and capture with the VLAN. And it's learning from the leaf 1. Okay. If we do the show NVI VNI all detail, so it's showing the now this NVI is up and it's in a hardware program in place. This is the VLAN bid and it's up. Okay, so this is how when the inter subnet communication will happen. So it will use the L3 VNI. Let's show the leaf 1 also. Before that, if we check the entry for that in the DNC manager, show forwarding VRF blue, where you can see for this subnet showing the dash behind this leaf interface is this, and this is the VNI needs to be used. Okay. So VNI detail. So this is the VNI which is for this 202 subnet. Okay, host 3. Okay, VNI 500 is up. And here also show forwarding VRF blue, which is the host which is connected on the VLAN 500. As here we have an SPI for this, and this VLAN is passed on the source panel to VLAN 500. This is the port which is connected behind, connected to host 3.